This video uses some software called Fritzing to develop some schematic and layout drawings for a really simple circuit. First thing we're going to do is bring in an Arduino Uno like ours and rotate it so it's in the orientation it is on our lab breadboards, and add a solderless breadboard. So we're just getting the hardware in that we're using in our lab. Now by adding that and bringing it down to the same size, the half size version, we'll have something that looks a lot like what we have in the lab. Now we'll have to rearrange it to get it into the center of the screen on a reasonable scale. Switching to the schematic view, we can see a block diagram for the Uno, and we'll try to get that into an appropriate size in the middle of the screen too. You don't need to use Fritzing to draw your schematics and layout diagrams. Pencil and paper should work just fine for the rest of the course. We don't see the solderless breadboard in the schematic because it just acts as wiring to connect things together. We will see it in the breadboard view. So now I've added the photocell and the resistor that are going to be the components in our small circuit, and I'll hook up the contacts on each of those together with the wiring tool. When we switch back to the breadboard view, we can see that the wiring is all there electrically, but it's not very tidy. So let's move some parts around and put some wires into the system so that it looks like the actual construction that we'll build in our lab. When we switch back to the schematic view, we can see that nothing's changed. We can tidy it up a little bit so that it's a little easier to read too. We can rearrange the wiring on the breadboard to make things more compact. It doesn't matter how we lay it out as long as we keep the electrical connections in the same topography. We'll still have the same schematic. Note how the red wire from the Arduino connects the 5-volt source to the entire red row along the right-hand side of the solderless breadboard. Likewise, the black ground wire coming from the Arduino. So we don't need to, in more complicated circuits, make multiple connections to the ground and 5-volt supply pins on the Arduino. On the schematic, we can use the ground and +5 symbols to show that these different segments of the circuit are actually connected together. That's going to be way more important when we start looking at more complicated schematic diagrams, and we don't want a lot of spaghetti running around like a rat's nest to confuse us. I arranged the schematic to run from top to bottom, 5 volts down to ground, because that makes logical sense to me when I look at it. We may wind up rearranging our actual layout on the board to fit things in more tidily and more compactly. And as a result, the physical layout may not wind up looking anything like the schematic, but still behaving exactly the same way electrically. Well-formatted schematic diagrams help us understand what's going on in the circuit, and software can help us translate more complicated schematics into actual layouts on our boards.